1.5 talks about perpendicular lines. Lines are perpendicular if they form a right angle. A right angle is anything that forms a nice 90-degree angle, right? We can see that in our graph. Those two lines are perpendicular. If we are talking about the equation of two lines are perpendicular if their slopes are, number one, opposite, and number two, reciprocal. That means I'm going to take a look at their slopes. For the slopes of two lines, one should be positive, one should be negative. And then what does that word reciprocal mean? Jacob? Not, what does it mean though? Yeah, they're flipped, right? So opposite reciprocal means one positive, one negative, and then we flip them upside down. So let's take a look at some examples of what this means. If I am looking at 4/5, say 4/5 is the slope of one of my lines, and I want the perpendicular slope to that, what would it be, James? Negative, because the first one is positive, and I make the fraction flip upside down. So instead of 4/5, negative 5/4. What about, for example, 2? What would the opposite reciprocal to that one be? Branson? Perfect. Again, one positive, one negative. We flip that one upside down. What about example 3? Branson? Perfect. If I have a whole number, remember that we can rewrite that as negative 6/1. I take the positive version and I flip it upside down 1/6. Any questions on that part? Okay, let's do some problems. Now, what you're going to see in your homework and on this notes packet is all of the stuff that we've done so far are kind of going to be mixed together. So we are going to be determining whether they are parallel or perpendicular or none of the above. So, remember, parallel, we look at the slopes, we look at the y-intercepts. Perpendicular, we just have to look at the slopes. I have to get it into the form y equals mx plus b. My first equation is already there, so I don't have to change anything. My second equation, I do have to switch some stuff around. I need to get the y by itself, so I'm going to subtract 4x from both sides. And then I need to divide everything by a negative 3. Negative 4 divided by a negative 3 is going to become a positive 4/3 x minus 3. And now we compare. The first thing I'm going to do is look at the slopes. Are the slopes the same? Are they opposite reciprocals? Are they nothing? What do I have here? Jaden? They're neither. They're not the same. They are reciprocals, but they're not opposites. So this one is neither parallel nor perpendicular because the slopes are not opposites. Questions on that? Let's do it again. Example 5. I see now the second equation is already solved for y, so that's good. That's y equals mx plus b. What do I have to do to this first equation? I need y equals mx plus b. Cody? Yeah, but how? Divide everything by 4. Hey, when that x is by itself, when there's no number in front of it, and I'm dividing by 4, what does that look like, Cody? There's like a 1 in front of that x, so this is 1/4 x plus 3. Okay, compare my slopes. What do I have? Parallel, perpendicular, or neither? Autumn. Why? Perfect. If I write negative 4/1, we can see they are opposites, they are reciprocals. This is perpendicular. Getting the hang of it? I got one more for you. Flip it over to the next side when you're ready. All right, example 6. First equation, already solved for y. What do I need to do to that second one? Cody. Beautiful. Y equals negative 6 divided by 3 is a negative 2. Oops, x plus 3. What do we think for these two equations? Branson. Why? What's the word? But not the what? Same slopes, different what?
This is Cody's answer, by the way.
Yeah, different y-intercepts. So the slopes are the same, but these y-intercepts, they are different. All right, good on the equations. I feel like we're good here, right? Make sure you're solving for y before you answer your problem. Let's take a look at how do we solve this from a graph. Again, we're looking at the slopes. So the first thing we need to figure out are, can we have parallel lines here? They have the, oh no, they don't have the same y-intercepts, but they don't look like they're parallel, right? They intersect. We already know that parallel lines never intersect. So I'm trying to test if these are perpendicular. I'm counting my rise over my run. Let's start with line A, which is that one going this way. I'm going to look at those 2 points. The first thing I'm going to do is count my rise, then my run. I always go from left to right. So I want to count down, 1, 2, 3. That's my rise. Then my run, 1, 2. So the slope of this line, negative 3 over 2. Do we see how I did? Rise, run. Okay. I'm going to do the same thing for line B. I'm going to pick 2 nice points. I'm going to go from the point on the left to the point on the right. I go rise, 1, 2, run, 1, 2, 3. My slope, rise over run. What do we think for these 2 lines? Cody? Why? Perfect. Any questions on these? Now, we're going to go back to writing the equations. I am not changing my process at all. Every single step is the exact same. What are those 3 steps? Can somebody remind me? Step 1, when I write an equation, I always start by what? Jacob? Finding the slope. Once I have the slope, I'm going to start writing my equation. What form do I start with? I heard somebody whisper it. Point slope form, y minus y1 equals m times x minus x1. And then once I'm in point slope form, my instructions always say get it into slope intercept form. How do I get this equation into slope intercept form? James? Solve for y. I have not changed these 3 steps. They are the same 3 steps we did yesterday and the day before. So, looking at example 8, I want to write the equation that passes through 2, 4 and is perpendicular to y equals 1/3 x minus 1. So step 1, find the slope. What slope do I need for my new equation? Cody, how do you know? We take that slope, we find its opposite reciprocal. Its opposite is negative, its reciprocal is 3 over 1. We know we can write that as just negative 3. Yeah. Okay, step 2. Can somebody help me out write this equation in point slope form? Go ahead, Cody. Beautiful, right? We're doing x1, y1. Step 3. Now that I'm in point slope form, what is my first step? Go ahead, Cody. Yeah, how? Distribute the 3. And then what? Go ahead. So my new equation is y equals negative 3x plus 10. Any questions on that one? Okay, somebody other than Cody's going to help me out with example 9. I said somebody other than Cody. What do I need for step 1? Branson, are you just going to give me Cody's answer?
No, it's a slope.
Okay, how am I going to find the slope?
You do the opposite of 4.
Hold on. What do we need to do first?
Oh, you have to divide by 2.
Yeah, we have not gotten this into y equals mx plus b yet. So I can't find the slope until it says y equals. So I'm going to divide everything by 2 first. Y equals negative 2x plus 5. Now I know what the slope of this line is. Now this slope is negative 2. So what slope does my line need?
1/2.
Positive 1/2, the opposite reciprocal. Any questions how we got that? All right, who can write my equation in point slope form for me? I said read. Y minus negative 8.
Yeah.
Mm-hmm.
Equals 1/2.
Mm-hmm.
And then in parentheses, x minus 6.
Beautiful. Jaden. Perfect. Then what? Oops. Yes. Beautiful. Any questions on those? We feel good about this process. I'm trying to hammer it into your brains so we never forget it ever. All right, take a look at the last application problem. Remember yesterday we did this application problem with parallel lines? We had to figure out the slopes to figure out if they were parallel. Now we're doing it with perpendicular. We're figuring out the slopes to figure out if they're perpendicular. What equation do I need to figure out the slopes of these two streets, James? Our what formula? Beautiful. Our slope formula is this. y2 minus y1 equals over x2 minus x1. So I'm going to do that equation for both of my streets. Let's start with Park Street, which goes through those two coordinates. Can somebody help me set this up? Go ahead, Cody.
Wait, the 5, 3, and 8, 5?
Yep.
5 minus 3 over 8 minus 5.
And that simplifies to? Beautiful. I'm going to do the same thing for Langdon Street. Somebody other than Cody want to set this one up? Jaden. Simplifies to? Beautiful. Now, what do we think about these two streets? They are perpendicular. Why? I heard whispers. Opposite reciprocal slopes. All right. Any questions on that? Beautiful. All good.